Alrighty, welcome again to another problem solving video as part of my documenting process of my journey of landing a job in tech. This is day 3 of our solving problem videos series I'm trying to post. I'm trying to or not trying. I'm documenting the journey, so to speak, of the process of me applying for different tech jobs. Again, for the ones who don't know, I'm trying to transition from being a business owner. I own a marketing agency, which I've been running for the past 5 years. As my side job first, and then it became my full time job at some point too. So, in the process, I discovered that I really wanted to pursue my passion in programming, um, software development, um, more professionally. So I decided to make the leap and start learning other programming languages away from um, basic website builders, a little bit of HTML, CSS. I learned some JavaScript, but I've been learning Python for the past 2 years, and I really put myself in a position where I want to land a job in tech. So yeah, this is a little introduction. It normally takes me around 2 minutes, so just for the people that don't know me, and are trying to follow up and do the same thing. Maybe you are in the other side doing the same thing, and this gives you a little motivation. But this also serves me as a way to keep track of what I'm doing and keep myself accountable of the process of solving problems. Also, it's great for practicing, technical interviews too, speaking out loud. Like once you're solving a problem, speaking the problem out loud on camera, that helps a lot. So yeah, that's the whole um, that's the whole dynamic with this kind of video. So the problem for today, we normally try to solve two problems in a day. Sometimes we just solve one based on time. It's 8:26 here on October 2nd of 2024. So yeah, here we go. Given a 5 positive integers, find the minimum and maximum values that can be calculated by summing exactly 4 of the 5 integers. Then print the respective minimum and maximum values as a single line of two space-separated long integers. Okay, so we have an array of 1, 3, 5, 7, and 9. The minimum sum, this is so funny, 1 plus 3 plus 5 plus 7 equals 16, and the maximum sum is a different permutation of those same numbers. Complete the mini max sum function that are below. Mini max sum has the following parameters: an array of 5 integers, so that's the input, and we print two space separated integers as we see here on one line, the minimum sum and the maximum sum of 4 of the 5 elements. So we see here we have 1, 3, 5, 7, and 9. 1, 3, 5, 7, and 9. And then we have 3. So here we are. This is where we're basically, this list right here is sorted from minimum to maximum. So it makes sense that for the minimum, we are going to skip the last value since the last value is going to be the higher. And for the maximum, we are going to skip the first number since it's sorted from min to max, me being the first number being the minimum, right? So We don't have to return anything in the function, basically it's telling us to print. The input format is a single line of 5 space separated integers. Constraints, we have 1 is equal, it's minus or equal of the elements in the array, minus equal 10 to the power of 9. So every element in the array, so we don't have to worry about negative numbers, basically is what it's saying. We can have large or long integers, so to speak, but we don't have to worry about edge cases with negative numbers. Output format, we already saw that. Print to separate, space separate long integers, okay. Denoting the respective minimum and maximum values that can be calculated by summing exactly 4 of the 5 integers. The output can be greater than a 32-bit integer. So that's where the long integer comes in place. In Python, we necessarily don't use long integers. Python magic, but for other languages, like C, C++, Java, you have to specify long integers for terms of memory. Also Swift, the Swift language. I've been learning Swift for the past 6 months too. Very nice, very beautiful language. I mean, at least for me, coming from a different type of languages that are less structured, Swift is type-based language, if you will. So, but yeah, Python is great for interviews and practicing code because you're still putting the logic behind and creating the order in your thinking process. You create the order of the algorithm. Doesn't matter the language. It takes some of the syntax complexity away, right? So we understand the problem. Sample output for the sum, and again, so the minimum, it's going to be in this side, and the maximum is going to be in the right side. So in this case, it's going to be minimum 1 to 4, right? So 1 plus 2 plus 3 plus 4, and then for the maximum will be 2 plus 3 plus 4 plus 5. So as long as the list is sorted from minimum to maximum, we can do this in a straightforward way, because we're always going to ignore the last number for the minimum sum and always going to ignore the first number for the maximum sum, right? Because this should be the values that change the sum. I said earlier, I laughed earlier when I was reading the problem up here, because I recently did one of the IBM assignment interviews. I applied for one of their jobs and they sent me the coding assignment, and one of the problems was something similar. It was a medium difficulty problem, right? This is an easy one. But the other problem was basically it was like permutations on an array, and you had to count the frequency of those numbers and return the minimum sum or the minimum cost of all those numbers in the array. So that's a different problem. I'm not gonna make the video longer, but it's very similar. You can see how this is the foundation for that kind of problems, right? Where you start manipulating sum or operations in an array. Simple arithmetic, but also you learn how to manipulate these numbers or these integers in array. So pretty cool. I guess going through the problem took me a little longer than normal. I have somewhere around 9 minutes now. I normally do this in like five minutes, but took me like 7 actually to 3 minutes of introduction, so we're good. The numbers 1, 2, 3, and 4, and 5. Calculate following sum using the 4 the 5 integers. Sum everything except 1. The sum 14. Sum everything except 2. The sum is 13. Sum everything except 3. Sum everything except 5 is this. Hence, be aware of integer overflow. Use 64-bit integers. This is a good point here. However, I don't think we do have to worry about that in Python. And if we do, we'll find out and we'll debug that, and that's part of solving this problem, right? But yeah, let's see how we can approach this problem. Sweet. Okay. I don't have access to the second screen here to show some of the things I do, so I might bring it to the main screen now that I know that. Excuse me. So I'm trying to think here because in this explanation right here, it says, sum everything except 1. The sum is going to be that. So yeah, so basically, it's a long way to tell you that as long as the array is sorted, for the maximum sum, you are going to ignore the first number, and for the minimum sum, you're going to ignore the biggest number, which is the last integer. So yeah, all this in between, unless necessary, can be avoided because we already know that the list is sorted. Now, for interview purposes, talking about complexity of the algorithm and time complexity, so to speak, sorting an array, because it doesn't say here that we're going to get a sorted array. So if the array is not in order, then that might be a problem, right? That makes the problem more complicated because we will have to sort the array, and that's at least using the sorted method in Python, and that's a big O of an operation, right? Because we have to go through every number and in the list or the array and organize it based on its value. So that adds a little bit of time complexity, but again, we'll find out because it doesn't say given 5 positive integers. Yeah, it doesn't say that the list is going to be sorted. So we definitely will have to sort the list to solve this problem in a more easy, or like an easier way, right? Anyways, let's not tumble around the same things. Let's see here. This should be. I'm gonna open my little whiteboard, anyways, just as part of the process I like to follow. I'm very comfortable just kind of drawing things. So we're gonna have an array of 5 integers, we already know, and that array of 5 integers is gonna look somewhere like this. Let's not make it so weird. So this is our array. And we're just gonna add an extra one here, right? It doesn't have to be perfect. I say it doesn't have to be perfect and I try to make it better. Anyways, we have, let's assume that it's going to be sorted, right? So let's go by saying we're going to have 2, 3, 5, 6, and 7, right? We're also not following any specific order, right? So we are going to basically say that we're going to iterate over the whole thing because we have to add these numbers. So we're going to iterate over the whole array to be more professional. And for the minimum sum, basically what we said is, wow, my some days your drawing balance is lower than others. So we said for the minimum sum, the concept is basically ignore the last digit. Just bear with me here. I don't know why at least I'm pronouncing when I'm writing, because it looks like some different type of language. And I promise you it is not English. Alright, here we go again, people. I'm gonna try to write ignore here if I remember. Alright, ignore the last digit for the minimum sum. For the max sum, we are going to ignore the first digit. This is also, as we said, assuming that the list is sorted. So if the list is sorted, this should be pretty straightforward. There's nothing else I want to draw here, because it's simple. I think it's simple, right? I think it's simple. I could be totally wrong. So, a few things I like to do. I could just go ahead and whip a little for loop here. But I'm trying to follow a process where I learn, because the whole purpose of this is, the whole purpose of this is learning. And right, I'm practicing for an interview setting, but also the things I don't know or the approach I want to take, I like to digest it first, so I really learn and understand what I'm doing, and then I go and solve the problem. Oh, guys, excuse me, but I think I was a little dehydrated there. Anyways, let's go ahead and solve this problem. How are we going to approach this? We can do a list comprehension, we can do all kinds of things, but I'm going to say so I can say for every item in the array, for every number in the array is already an interval, so we don't need to use the range. So for every number in the array, I'm gonna say max. So let's do the minimum sum first. Min sum, it's gonna be equal to slicing here, the minimum sum is going to be equal to all the numbers in the array except the last digit, right? We are going first to try this assuming that the list is sorted. Now, based on the results on the test on the first run, based on how the test is designed, but that's another thing of these kind of problems that you don't know how the test really looks like. So yeah, the minimum sum is going to be equal to I can also start the sum as counter, start the sum variables before as 0 and then update that accordingly. What am I doing here? So yeah, let's see. The minimum sum is going to be equal to, so should I go for every number in the array, I'm going to go and add that number to the minimum sum except the last number. So from it's going to go through every number in the array. Well, I feel like a list comprehension would be awesome here, but it will have to see how a list goes. I have to refresh my memory on list comprehensions, to be honest. But the minimum sum is going to be equal to, I should have probably opened a Jupyter Notebooks and do a couple things here and there just to test the code, which is 100% fine. But let's see here. Okay. I feel like I'm literally staring at this thing, and I really know what I have to do. My energy levels are dragging me away. Okay, so the minimum sum is going to be equal to all the elements in the array except the last digit. So how do I create a sum that would add every n in that array except the last number? The reason I think a list comprehension would be great because as I can say minimum sum is equal x for or n for n in the array, slice that array, then do another list comprehension for max sum and slice that array too. Oops. Okay. Let's try to do that. I don't know why you're selecting the whole thing here. Did I change my... I don't know if I changed my shortcuts here. Weird. Yeah, my keywords a little weird. Anyways, I'm gonna say min sum. I'm gonna try to do a list comprehensions to here. It's gonna be equal to, well, I don't need an array. And for n in array from the beginning
I was out there talking to Alan down the street. That guy Alan on the other side of the bars that had his house for sale. So, I didn't have him.
Um, Let me just quick refresh. Um, Array slicing. Array slice Python. That's perfect. Python array slice start stop step. Okay, start stop. Okay, I really need to. Okay, slice start from the beginning. Stop at index 3, so 0, 1, 2, 3. 1, 2, and 3. 0, 1, 2, 3. Not inclusive. Zero, 1, 2, inclusive. So okay, slicing with steps, negative indexing. -1, -2, and -3. Start from here all the way down. This is funny. This is the meme, the Python meme with the how to invert an array in Python, and people use this. Okay. Yeah. So from the beginning, from the beginning to the -1. Let's see if we get that. So okay. Okay, I think I got that. I just need a little refresher. I don't need all this. All I really need is this. That's the minimum sum because we want to sum all the elements but the last one. And the maximum sum, we want to say and for n an array from 1 to the n. And then we print min, print min sum. It says space separated. Print two space separated long integers. Okay, space separated. I don't think you can necessarily do this here. This might be what is wrong here? White space before. Oh. Duh. What's wrong here, my friend? Valid syntax. Oh, yes, okay, here. How do we print that space? We could say plus space. What was that? Some Python JavaScript magic here. Let's see if that works. Let's just see what we get. I need to see the outcome. Ooh, terrible. Yep, we're saying, hey, you have a type error. You can only concatenate lists, not strings, to list. Because I'm doing a list comprehension here, and I have to print integers, not list. But let's just go ahead and do this, right? Let's just go ahead and debug our output for simple terms. input, your output is printing the 1, 2, 3, and 4. 2, 3, 4, 5. Okay. At least we know that the list now is going to be sorted, right? So we have a sorted list. Here we know we're not doing the addition, right? Which is the main part. But we know now that the list is sorted and we perfectly avoided the last thing. So n for n. So I have to say n plus n for n in array. And that'll do our addition, my friend. Now the problem is that we are definitely returning a list, and that's not the output we need. But again, 2, 4, 6, 8. Okay, because I'm adding it in the list, right? So input 1, 2, 3, 4, 5. I'm doing I'm doing 1 plus 1, 2 plus 2. Okay, and that's not it. See, again, I needed to practice my list comprehension. N plus n 0, 1, 0. N plus n, because I can say n plus. This makes no sense. This makes no sense, okay? Just bear with me. No, that makes no sense because you're talking. Yeah, that makes no sense. I'm not even gonna try that. Okay, we did a little try. Now we know the list is gonna be sorted, and we have we know that work. We know that's some sort of logic that would avoid, right, the first and the last. That's what we want, but that's not the process because we're printing the whole array and we're not doing operations. So n for n plus n for n plus n in array. Nope. I can iterate from. You know what? Honestly, we can do this. For every number in an array, we slice it from here. This is going to be the minimum. We say from the beginning minus the last number, right, till the end, not inclusive, the last number. So for n in array, min sum is going to be equal to min sum plus equal n. Min sum start at 0, max sum start at 0. For from 1 to the n, maxsum plus equal n. Print this should be integers, so we should be allowed to add the space here. Max sum. Let's see what we get with this. Okay, Python, I appreciate you telling me. Okay, my output is double. Oh, what the heck? I don't know how that happened, but yeah. So test case 0 is good. Sample test case 769 221. Huh. So the list is not sorted. Right. So let's go back to the drawing board. Yeah, because obviously I'm assuming the list is sorted, but the list it doesn't say it anyways or anywhere. Is what I'm trying to say, that the list is sorted, so I have to assume that the list is unsorted. So again, this approach could be totally wrong. It's all good. Remember, this is the part of the learning process, but we're gonna say sorted. All right, it's gonna be equal to sorted, and that's gonna be the array. Now we use here the sorted array. Same thing here. And the reason this is okay is because we are iterating over the same thing. So we are not iterating over two different things, so we won't be like this operation by itself. This itself adds a, what's it called? This itself adds an ON operation, right? We already know we have to go through the whole array to sort it. Same thing here, right? So we are iterating over the same thing. I could be wrong again, but I think we're not exceeding our big O n, which is going to be the, we have to iterate over the whole array, so we already know we're going to have our ON operation at least. So there's no logarithmic big O log n here. So let's just see how that comes out. Okay, yeah, sorting the array should work for both cases. This case also works because we take, this is what they gave us, we sorted that, so we make that 2, 7, 69 to 21, and 8,974, and yeah, 299, 9,271. So that is an approach. That is definitely an approach. I feel confident submitting that. Now, I don't think that's the most optimal solution, but again, as part of my learning process, I try to implement the brute force or the iterative solution, the first solution that comes to my head after a little gathering, right? You guys saw me drawing here. Right off the bat, I got the logic of the problem, you know. So again, we can make this um, maybe more readable. We can make this maybe more efficient. That could be a follow-up, and that's what I like to do. A second part of this video, I would go maybe to Claude and ask how can I make this um, how can I make this more efficient in time complexity or space complexity. Space complexity right off the bat, I don't think I'm doing anything crazy. I'm creating a new array here, and I'm creating a couple variables. So couple variables, couple pointers here and there for the language we're using, garbage collection and all that. We already know efficiency is not the main key of this specific problem I'm trying to solve. So I don't think we're, at least in space complexity, we're not going out of bounds. We haven't yet hit the integer overflow. But I don't think, again, as I mentioned, I think Python, part of the Python magic takes care of that. So if we were coding, let's say in Java or C++ or a bunch of these languages that are a little more robust, Rust, Swift, definitely we would have to worry about that. But for now, let me go ahead and click submit. Let's see how that goes. Let's see if we pass all the test cases. Maybe we don't. And so far, I think we did. Ready for this test case? Yep, we did. Yep, all of them. So that was an approach. That was definitely an approach we could minimax them. We could have taken. Now, as a follow up for myself, can I do this without having to sort the list? Right? Should I go into permutations? So many things. So many things I can go through, but yeah, I think problem wasn't really too hard, at least for the iterative approach we took. For an in sorted array. So now, can I make that more efficient? We don't even have to worry about the output because adding a comma here would automatically add the space. Let's see what class is. Let's see what class is. Oh, well, that's not cool. I was asking for a friend. Minimum cost permutation, optimizing staircase. Yeah, I think this is a similar question I asked. Universe setting. Space. Well, that was the last problem. That was kind of interesting. Let me say here for the next problem. I have these algorithm. what is the actual time complexity of it, and how could I improve it for an interview setting? Then I would normally just pass the code here. It's interesting because probably like back in the days you used to know how to do this on Stack Overflow or something like that if you didn't know the answer, or figure it out yourself, which, but it's not a bad idea, you know. But also it's like these tools are here for us to learn from them too. Um, so I never discard the possibility of learning from these tools. So make command sound array. I guess I'm not passing the context. See, I don't like to do this. Let's see. Let's analyze time complexity of your current algorithm and then discuss how we can improve for an interview setting. So that this operation is that time complexity of n log n. Excuse me, where n is the length of the array. In this case, n equals 5. The two subsequent loops each iterate over 4 elements, which is a constant time operation. So that's another thing. Like we're iterating over a set array, so that input would never grow, right? So um, that's another part. That's another reason why I like to do this kind of stuff. See, in my head, I have to refresh. I have to go back and obviously keep learning because I can't slip things like that. But also, it's nice to have that here and just remember immediately that's the way it should work. It's like duh, yeah, we're iterating over the array is always going to be 5 numbers. We're always going to iterate over 4 numbers, so it doesn't matter the um, the size of the integer itself, right? So 32-bit 64, it doesn't matter because it's always going to be constant. That array won't grow, so our operations would never scale in that sense, right? um, it's fixed at 5, yeah. Therefore, the overall time complexity is dominated by the sorting operation, making it big O of n log n, or more specifically 5 log 5 in this case, right? Because it's always going to be fixed to 5, n equals 5. So, therefore, yep, while this solution works correctly, we can improve it for an interview setting by reducing the time complexity to big O of n, or even constant time given the fixed input size, eliminating the need for sorting. Cha-ching! Performing the calculation in a single pass through the array. I haven't looked the code yet. I swear I'm not looking down here, and I'm trying to think. Um, I'm trying to think how to do it because yes, I can. It's a set of 5 numbers. I can just go and say, is this number less than this number? Yes, add it. Is this number? I don't have to sort. Um, okay. Length not equal 5, raised value error, 5 integers. We don't have to worry about that because we already know that the array is going to be, we don't have that edge case particularly in our test because we saw that with our big O n log n algorithm we have here. We pass all the tests, so we don't have to worry about edge cases of this matter. We have a total sum, minimum value, and maximum value for numbers in the array. The total sum is going to be plus equal the number. Minimum value is going to be equal min value and the number, max value and the number. The solution has a type complexity of big of m, where n is the length of the input array. In this specific case, since n is always 5, it's effectively a constant time operation. We're using only a few variables we have in precise, so the space complexity is big of 1. One pass through array, which is more efficient than sorting and then iterating twice. No sorting, we've eliminated input validation, whether check to ensure the array exactly, flexibility. This is awesome because this is such a core of actual programming, actual computer science, and things that you have to think about. And that's the that's the thing with these kind of problems, that you are obviously starting easy. Like I'm a total beginner, right? I'm learning and I'm doing all this thing for the sake of learning, and but you don't think about stuff like that. You don't think about initializing min value to infinity and max value to negative infinity, which are correct behavior even with negative numbers in the input. We know for a fact that in this problem we don't have to worry about this kind of edge cases, but that is actual programming. That is exactly actual programming, because you would have to worry about that in this kind of checks and edge cases. It's what makes a good programmer a good programmer, and I've seen it, right, with a bunch of professionals I follow in different social medias and whatnot. But yeah, that is what I aspire to be. So that's awesome, and that's why I also like to use these tools. I try to solve it myself. Then I come here and humble myself down and be like, hey, how can I make this better? And just learn from it. Some things I know might not work in this particular problem, and I'm gonna try to implement it. But it's awesome to see that. Variability is grocery farm easy to understand which values the interview setting. In an interview, you could also mention these solutions assume the integers can be safely summed without overflow, which is something we also know by the hint we have in the problem. If dealing with very large numbers, you might need to use a language or data type that supports arbitrary precision arithmetic. If asked about further optimization, you could mention that, for a small fixed size input like this, a solution with explicit comparisons might be faster in practice, though less elegant and less flexible. True. A, B, C, D, and E equals the array. We're basically, how do you call that? we're basically unzipping the array and or decomposing the array, right? By the 5 elements, and then saying, hey, the total of that sum, it's going to be all the elements. The minimum of that sum is the total, so all the elements minus the maximum. Without the sorting, we're already using the maximum and say, hey, from that total, take the maximum from all these numbers, and that's my minimum sum. From my maximum sum, this is awesome actually. That's what I aspire to be. That right there, that last paragraph, it says, by presenting this optimized solution and discussing these points, you demonstrate not just coding ability, but also analytical thinking, attention to detail, and understanding of algorithm efficiency. I like this. I like this a lot. I like this one better than this one. Um, Even though this one's more professional and checks for edge cases. Um, but for the particular problem we're trying to solve, I like this one a lot because I ignore, like, I completely ignore here that I'm always gonna have five integers always in that array. And yeah, I'm saying here, hey, you know, ignore that last one, ignore the first one, um, and that's always gonna be my result, right? But this is just better because you're right off the bat. You say, oh, I have 5 elements. Okay, let's split those 5 elements. Give me my total. Give me my minimum, my maximum, and that's how we're gonna solve that. I'm gonna try to implement that one. Um, but I'm going to open a Jupyter notebook because this is another thing I like to do. I like to save. Um, I like to save this type of code and come back to it later and analyze and see like how was my first solution and what I learned with this solution particularly, and go from there. Man, I was so dehydrated. Um, all right. Here we go. I just gotta get to Jupyter notebook. Here we go. Practice. Rank. So here we go. This is mini max. Just gonna go ahead and grab my first implementation here. Just give me like whatever. I'll take this. then I'm gonna say improve implementation. What am I missing here? Implement. What do you mean? Why is it that I have it right, but that thing is it's not grabbing the. Yeah, implement. No interest for implementation. You mean implementation? Yeah, that's what I meant. That's what it's written here. Anyways, um, we said that the this version basically what it does is unzip the 5 elements of the array. It says that's equal the array. Then we say total. I'm actually gonna do it right here. I'm gonna say total. It's gonna be equal to A plus B plus C plus D plus E. And the min sum is going to be equal to the total minus the max of the max of the total max of all the max of all the max of the total. Is that what that is? I'm not gonna look it up. I'm gonna try to implement it myself. I already got the idea. Max sum equals total minus min from that total. Then you print min sum max sum. And then I'm gonna use the same input. Let's see what we get. Yeah, it's not the total. It's terrible. It's the array. Is it the array? Yes, it is. It is the array. Yeah, and that's the other implementation. Unzip the array by the 5 numbers. Add those numbers together, and that's your total. Then your minimum is that total minus the maximum in that array, and your maximum is the total minus the minimum in that array. That's beautiful. I hope that works. I really love that solution. I don't know why. I just think like it's so genius. I didn't came up with it, but I learned from it, right? And I know how it works, and that's the whole point of the learning process, right? I implemented my first solution. I knew it was not the best, but I understood what I did. Now I look up how to make it better, but I know how it works. So I learn from it. I implement it myself, just knowing how the logic works. And I type it here. I'm gonna go ahead and type it here again, and that should stick to my brain. That should stick to my brain. Whatever I'm doing, it should stick to my brain because I know what I'm doing. Equals to the array. And right there we said the total is going to be equal to A plus B plus C plus D plus E. Right. Yes. So A plus B plus C plus D plus E. That's their total. And our min sum is going to be equal to the total minus the max in the array. Oh, max in the array. And the max sum will be equal to the total minus the min in the array. Sometimes I forget about those functions. Like max and min, I forget about them. I need I'm trying to read the documentation of this thing. It's just telling me, hey, you haven't used this. That was beautiful. That was beautiful. Let's go into the next problem. That was awesome. Let's go.